All right, did you do it? Did you draw the arrows on your paper? If you haven't done that yet, you need to pause this video and go back and do that. This discussion will make a lot more sense if you've drawn those arrows. Did you do it now? Did you draw the arrows? Okay, I'm going to show you where these arrows ended up, and I'm going to share with you also a few key points of mathematical importance. Okay, so one of the things I notice when students do this in class is, even though I never actually said the word congruent, you guys naturally did that. And if you don't remember what the word congruent means, well, you actually use that geometric principle, the idea of I need to make congruent figures in order to draw all of these arrows. This original arrow, most of us don't move every single corresponding point. Most of us look at it and go, okay, I'm going to move this part, and then I'm going to kind of go, all right, this has 3 and this has 3, and I'm going to move a part that makes sense to me, and then I'm going to get the rest of the figure from there, because I recognize that if this piece is being flipped, or if I'm going to spin it. So here were some of these words down here. So the rise and shine arrow said the word flip. And I'm going to color code these as I talk. The I like that arrow also said the word flip. Both of those said the word flip. And I think we recognize when all you do is take something and flip it, that it's not going to change size or shape, right? It's like looking in a mirror. If you look at yourself in a mirror, you are flipped. Or if you look at yourself making a Zoom video, for example, right now, recording yourself, you are flipped, but you are all the same proportions, all the same size, all the same shape. Okay, so there is a much better, so you can check and look here. This like peachy color was the rise and shine arrow. Now I'm going to tell you one of the things that I see students do is sometimes they flip it right next to it. So double check here. This said flip the arrow over the x-axis. Well, this is the x-axis. So if you're wondering, why did she draw it up there? If you're looking at yours and mine is higher than yours, to flip it over the x-axis, that means imagine for a second that I folded my paper on the x-axis. If you fold your paper on the x-axis, this new arrow that you drew should land right on top of the original arrow. So we have this original arrow, and if I drew it just right next to it, or some people attach it to the x-axis, if it says flip over the x-axis, I should be able to fold on the x-axis and have my new arrow line up exactly with that one. And the only way that's going to happen is if I make it, see how this distance right here is 2? That's 2 away from the x-axis. That means this distance here also needs to be 2 away from the x-axis. That's the only way the fold will make the correct flip. Now, likewise here on number 2, we now changed that to flipping over the y-axis. So if I'm flipping over the y-axis, that means now this distance, 1, 2, 3, 4, 5, needs to match this distance, 1, 2, 3, 4, 5, because now I need to look at this as if I'm folding on the y-axis. If I were to take my paper and fold it on the y-axis, I want my purple one to line up exactly with the original. And the only way they will do that with a flip is if you go as far away from that folding line as you started. Now, I keep saying flip and fold and all these things. There is a much better mathematical word for both of these. And I mentioned looking in the mirror. A flip, this rise and shine arrow was really asking you to draw something called a reflection. That is the official math language for flip. We'll still say flip every once in a while to remind you, but we're going to get very used to calling those reflections instead. And that's not a brand new word. We've all used a mirror before and know we're looking at our own reflection when we do that. But that is the idea of what you actually created as a geometry term. And I bring up that word geometry because you guys, we finished up last week our functions strand. That's crazy. That means we have worked through the NS, the number system strand. We've worked through a million standards in the EE strand, equations and expressions. We've now worked through a bunch of standards in the function strand, and we are moving on to geometry. This is the 4th out of 5 strands we do. We have geometry and then we have one more after that, you guys. It's crazy. Okay, so starting with geometry, we start working on these different movements. Reflections is one of them. So that's going to be an important keyword that you need to get in your brains, and we'll learn a ton more about it this week. But overall, at its most basic level, a reflection is a flip. Okay, obviously we're going to make it more mathematical than that, but make sure you can recognize at its basic level, a reflection is a flip. And that's what you created with the rise and shine arrow and the I like that arrow. Okay, next you did the sleepy arrow, slide the arrow. So you've got this keyword slide here. Slide the arrow 16 spaces to the left and up 10. Actually, this is maybe the easiest one just by definition of what's going on, but it's actually the one that students mess up the most just because it's easy to miscount that as well. So when I talk about this in class, I know a lot of students, I mean, are you moving every single point? You can, but you can see I drew this dot here and that corresponds with that dot there. So I actually just moved the one dot. I counted over 16 and then up 10. And then I filled in the rest of my congruent figure because I recognize that if I flip a figure, it stays the exact same shape and size. But also if I slide a figure, it stays the exact same shape and size. There is a better word than slide for this. I don't know if you've heard this one. I know you've heard the word reflection, but I'm not sure about this one. This one might be new. Isn't that exciting? So this word is translation. A translation is a slide. I didn't flip it. I didn't spin it. I just took it and moved it over and up. Okay, that's a translation. And then the last one that I did, wasn't the last one you had to do, but the last one that I did was the hungry arrow, which asked you to spin the arrow. And this gets tricky. You had to spin the arrow 90 degrees counterclockwise. Counterclockwise means the opposite of how a clock goes. So here's my original arrow, a clock, like you can imagine, noon, midnight, 12 up here, and then it goes 1, 2, 3, 4, 5. It goes around this way. So I had to go 90 degrees counterclockwise. This one can be a little trickier to draw. And for some people, if they left one blank, it was this one. So one of the easiest things to do to try and figure out how this works. First of all, there is a hint. It's called the hungry arrow. So that gives a lot of students this hint that like it's going to be facing the pizza. And that hint was given on purpose. Okay. But also if I look at this one is size 2 and it's horizontal. So that one is going to have to change to become vertical because a 90-degree rotation should create 90 degrees with these corresponding parts. Rotations can be tricky. So if you weren't sure on that one, that's okay, draw that. And I've just said the word a couple of times. Our official math word for spin is rotation. These 3 words are going to become key words for you, and you're going to practice them even just recognizing them on today's Canvas quiz. But the 3 words you need to know, and actually there's a 4th word, but the 3 words you need to know right now are reflection, rotation, and translation. 2 R's and a T, reflection, rotation, translation. And overall, all of these together are called, we're going to write this over here. You ready? They're called transformations. Why are they called that? Well, why are the transformers called the transformers? Because they change. They change what they look like. Now, these type of transformations, a reflection, a rotation, and a translation, they will change what the figure, where the figure goes, but they won't actually change what the figure looks like. So these type of transformations just change the position. Is it changing in a flip kind of way? Is it changing in a spin kind of way? Is it changing in a slide kind of way? But all of these transformations are taking a figure and changing it somehow, not the shape and size. It just changes the position. So this last one says, how do you feel about spring break? List a series of directions. Now, I want you, if you already did this, I want you to challenge yourself in your list of directions. And I'm not going to tell you what to write here because everybody did different things. But you were supposed to take this arrow and you should have one more arrow drawn on here that's either pointing to the frowny face or the smiley face, depending on how you feel about spring break. In your list of directions, can you include one or more of these new words? What you might have had before is you might have had spin, flip, slide. Maybe you only did one of these. Maybe you did a combination of these. But I need you to come back now and I need you to add some of these fancy words to it. This is the part you're going to take a picture of for me, is this page, so I can see your share your feelings arrow and I can see your math language that you use there. So pause the video right now if you need to, and rewrite your description of your directions. And I challenge you to try and use one or more of these words. Go ahead and pause me and fix that. Okay, and now we are also going to fill out the back side of this just to make sure we have an overall vision of what we're doing over the next couple of weeks for our first geometry standard. This first geometry standard does take a couple weeks to get through. It's a big one. So it says, looking at the examples and non-examples below, what does it mean for two figures to be congruent? This side has examples of these two figures are congruent, these two figures are congruent, these two figures are congruent, and these two figures are congruent. Does it look like the figures have to be facing the same direction? No, definitely not. They might have been rotated, they might have been reflected, or they could have been translated. Okay, these figures are not congruent. These two are being compared to each other. This figure is not congruent to this overall figure. Some students get confused. They're not individual triangles. This whole figure, not congruent to that one. This one, not congruent, not congruent, and not congruent. So what does congruent mean? Congruence means two geometric figures, could be more as well, two geometric figures that are the exact same shape and size. And we'll get more specific on that and what creates congruence as we move forward. But two geometric figures that are the exact same shape and size is congruence. If you have these type of things that create a congruent figure, we also call those rigid transformations or rigid motion, because they lead to congruence. That means just like on the front here, everything you did on the front was a rigid transformation, because this arrow is congruent to this one. It's flipped, it's reflected, but it's the exact same shape and size. This arrow is congruent to this one. It's flipped, it's reflected, but it's the exact same shape and size. This arrow is congruent to this one. It's translated, but it's the exact same shape and size. And of course here, this arrow is congruent to this one. It is rotated, but it is the exact same shape and size. So for all of this week, we are going to focus on rigid transformations. It moves the figure in some way, but it does not change the shape or the size. It keeps it congruent. Again, here's our three types. A reflection. A reflection is a flip of a figure over a point or line. I'm actually going to let you, after this video is done, I'm going to let you sketch these. And this page will be part of your binder check. So make sure you sketch these out. Okay. A rotation is a spin of a figure about a point. So this one, rotate the triangle 180. I'll give you a tip here with a rotation. You can actually physically turn your paper 180, would flip it upside down, and then you can sketch that. This one, 90 degrees. You can go either direction, but go 90 degrees about that point. So I'll let you sketch those. A reflection is a flip. You now have two reflections to sketch. Doesn't have to be perfect. Just do the best you can. Make sure you're actually flipping over the line. If you were to fold it, what would it look like? A rotation is a spin, sketch those, and a translation is a slide of a figure to a new location. So you guys are going to sketch those things and then take a look at what it is you're supposed to submit for today, and then try your Canvas quiz.